Or what do you want to do? Hail
What would
Mary?
you like to do? Hail Mary's always my favorite, but that's fine.
All
Good.
right. In the name of the Father, Son, Holy Spirit. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for our sinners now at the hour of our death. Amen. In the name of the Father, Son, Holy Spirit.
I guess that's good that you're all smiling so much while we pray.
Good job,
All right,
Jack.
gentlemen, this is a good one. I always say that every day. This is a good one for our beginning of our last 4 weeks together.
Hey,
What's that? Today's mustard seed, April 20th. You seem intent on taking the easy road, and I have tried over and over to gently persuade you to not. Let me tell you plainly and clearly, the easy road does not lead to heaven, and there are only 2 eternal destinations. That's a good one. I'd like to say the easy road does not lead to good grades on the transcript that are forever tied to your name. So we can do it. We can do it. All right. Hopefully, guys. Ben, nice to see you. Glad to have a video there. All right, gentlemen. So today I am going to introduce you to a new topic by giving you a little bit of a problem statement. So the way this is going to work is I'm going to share with you what we are going to be doing over the next 4 weeks. So you're introduced to that first before I teach you any content. After you read the statement, we are going to make a list of some information and how are we going to move forward on this. So this will be all 8 of you together trying to figure this out. So I'm curious to see how well I can manage this on Zoom. And the goal is that it gives you a little inspiration for learning, I hope. So with that said, I'm going to share my screen with you. And
that was a good one, Coach.
What's a good one?
Inspiration for learning.
Inspiration? You ready? Let's go. I'm excited. May 12th is around the corner. It's going to go so fast.
Talking to seniors.
And juniors, so that would be Ben, right? I get you for just a couple days after. All right, so here we go. Okay, everybody read this silently. I'll chime in and read it out loud, and then I'll tell you how we're going to go forward before you go into panic mode. All right, so let me find it here. I'm not seeing it. There we go. All right. All right, so you're being hired as an electrical engineer. My favorite subject, electricity, most useful. So here we are amongst this coronavirus pandemic. So along with biomedical or biological warfare, you could almost say, the other grid that is so protected is our electrical grid. So I can't even take students on tours anymore of electrical companies and so on. They protect our electricity tremendously. So imagine we were going through this and we didn't have any electricity. We would not be able to communicate.
No online classes.
No online classes.
Hype.
It would be a whole different scenario and quite honestly, pretty scary because health-wise, we wouldn't be able to be taking care of each other. We wouldn't have that communication. The electrical grid has become more important than water. And that's true as far as protection of it and its use of it and so on. So yeah, you lose electricity for a day or two, but maybe only in a section. But for the whole country to lose electricity. Anyway, I really would like to end our year on this topic because I think it is essential. As you guys are maybe considering careers in engineering, electrical engineering, high demand, extremely high demand. We started the year with electromagnetism. We took a look at, we went to VCU and looked at that as far as the research that was going on as far as electromagnetic waves being used in our electrical components. But, and that was all in the electrical engineering department. So very big area. So I thought, what better way to learn about electricity than in your home? Because that's where you're all stuck right now. So what does the electricity and the currents and circuits and everything look like in your home? So I'm going to challenge you guys to build me a model home with 8 rooms because you have 8 people in this classroom. And we're going to somehow try to build a little home. And so this is your scenario. You are going to build me a model and so on. So as you just read this, I want you to think of what information do you know from this problem statement? What do you want to know? And how do you think you'll find out? So one thing I've been trying to really instill with you is when you get out of school, you never really know what you're doing. It's a matter of applying the information you already know and figuring out how to get that information that you need to know. So if this is your problem statement, you know that this is what you have to do now over the next 4 weeks. So that's exactly how much more class we have. You have 4 weeks. We're going to figure this out. So what I want to introduce to you next, let me shut that off. See all your faces. Uh-oh, Frankie and Brock frowning. Can't show our faces. All right, I need to pull up another document for you all that we're going to work on together to try to figure out this scenario. All right, so I need your input here and we will begin. Let's see. Sorry. Okay, does everybody pretty much have that problem statement memorized in their heads? Okay.
Yeah, I memorize it.
You have it memorized, Jack? You got the basic scenario? All right, Frankie and Brock, I'm going to ask you to put your videos back on so I can see your faces as we do this next part. All right, so everybody contribute in, let's see in that one. Okay, so I'd like to work on this, what I would call a need to know board next. All right, so if we were to fill this out, okay, what do we know? What information do we know? And what do we want to know? So let's begin with that. So from the statement, don't read anything into it, but CJ, what's one thing that you know from that problem statement that I gave you?
It has to be done in 4 weeks or less.
Okay, awesome. Okay, what is one thing you should always write down? What's your time frame? What is your time frame? Matthew, what about you?
8 rooms.
What'd you say?
We need 8 rooms.
Okay, I mentioned that we need 8 rooms, but you guys can come up with a different scenario. We know we need a model of the house, right? So we know we need to build a model of the house. Jack, what about you? What do you know?
We're dealing with electricity.
Okay. All right. Ben, what do you got?
They want a lower power bill.
Okay, Frankie?
You can use all forms of electricity.
Okay. Brock?
I have no clue.
You have no clue. Did you read the problem statement?
No, ma'am.
I read it.
Let's
like, I was-
participate here, Brock. All right, pay attention, Brock. We got to finish out the year. You want to graduate. All right, Brendan, how about you? Anything you know?
There's 5 people.
Okay, 5 people in the house, which might be important on the electricity side, right? Because our electrical bill isn't as much now that there's not as many people in the house and so on. As you guys go on to college, you'll pay a bill, an electrical bill if you have an apartment. How does that bill get, calculated? What determines your electrical bill? Can you control that? Can you change how much it is? How much control do you have on that? And forms of electricity, what types are there? All right, so any other comments? Drew, what do you got?
They said everything that I thought of.
Anything else? Let's see if I can pull up something else here. All right, is that showing up? Is the problem statement back up for you guys?
No.
No? All right, let's do this way. Let's go back to, okay, I think what I want to do is do it this way. All right, so Brock, there you go. Read that again. Anything else we need to list on what we know, what we want to know? Drew and Brock, I need something from the two of you. Add to our list.
They want the electrical plans.
Okay, electrical plans, we didn't have that listed down. So we also need electrical plans. Brock?
Hey,
Got
bro.
anything there, Brock?
I have no clue.
No clue. Nothing you want to write down. It can be easy. You're an electrical engineer. So I took an easy one for you. You find something else. What do you read into that problem statement? What else do you know? What do you want to know?
Come on, Brock. You got it.
You got it, Brock.
Close
Please,
this
Brock.
dub. What's the dub?
I don't know, man.
All right, if we go back to this.
I think he said he wanted to phone a friend.
Okay, anything else that anybody feels we need to add to this list so we can move forward? And what would be the most important thing? So on that list right now, Matthew, if you were to pick 2 of the most important things that are listed there that we should keep ringing in our ears, what would that be?
We want a lower electrical bill. And electrical plans.
I would say 4 weeks
Plans?
through.
Okay, and we need electrical plans, so we need a low bill and electrical plan. All right, and what else is always very important to keep reading in the back of your head?
4 weeks or less.
4 weeks or less. So I mentioned that when CJ had picked that up right away at the beginning, our time frame. So keep that in mind. This is going to go very quick for you guys. All right. So yes, we're dealing with electricity. Yes, they want different forms of electricity. There's 5 people in the house. But, as far as what we have to be involved in, is it that important that we know that we're electrical engineers? It's definitely important to know how much time we have and what exactly we need. So I'm going to also highlight a model of the house. So we have 4 weeks to build a model, come up with the electrical bill, and draw the electrical plans that go with that house. So what do electrical plans look like? How do I calculate a bill? And how do I build a model? Like, it has to work. Lights have to come on. So if you know that's what you have to do in the amount of time you have to do it, let's come up with some questions. And you've been with me for a long time now. And I think I don't give you a lot. You have to ask the right questions for me to give you that information. So Ben, let's begin with you. What questions do you have? If I answered for you right now, you might be able to begin.
I don't have any questions.
No questions. You're ready to get started? If I said, okay, you got 4 weeks, go ahead.
How many rooms?
Okay, that might be a good question. Was that CJ?
Yes.
Happy 420, boys.
Okay. How many rooms?
8.
Good.
Lee,
You
you
already
open up
said that, bro.
Matthew, you got a question?
I thought we were doing it for 5
Uh,
people in the house.
Is there a budget?
Maybe there's 8 of us.
Now, do you mean budget for us or for the family's electrical bill?
Their electrical bill.
Both.
Okay. Budget.
Thanks, Matt. Wow.
Okay. Frankie, any questions?
how much energy do they need?
Okay, Drew, before anybody takes what you want to say, give me a question.
Okay, well, so is this like a physical model house that we're building?
Is this a physical model?
No, we're drawing it.
Yeah, could have drawn it.
Whoops. All right. Let's see. Brendan, any question? You're usually really good with questions. What question do you have?
What are you supposed to do?
What's that?
Classic.
What's your question?
That was the question.
I didn't hear it.
Oh, what are we like supposed to do exactly?
What are we supposed to do? Okay. CJ, you have a question? Or yours was how many rooms? Any others?
How do we estimate the electric bill?
Okay.
Why are we doing this?
What happens if there's too much energy?
It explodes.
Why haven't we corrected?
Then their Wi-Fi is better.
Wi-Fi is better.
Yeah.
All right, good. I like it. Shout out questions. What do you guys got?
What's the IP address?
Any more?
Are we putting everything we would want in our home in there?
Okay.
What's the Wi-Fi password?
How many outlets do they want?
Oh, good one.
Do they need a telephone line?
What appliances are they planning to use?
How many stories?
I feel like the more questions you guys ask, the more we're gonna have to answer when we do this.
Good, Drew, good.
Oh, you think that's how it works, Drew? I
You
don't
act
think
like
so.
you act like answering what is the Wi-Fi password is an actual legit question.
Okay, okay, now here's where we go. I'm going to stop you guys because one, I'm running out of room and typing, but you may have heard in the past, it is truly about asking the right questions to move forward, right? Somebody asks a question at the right time and everybody's like, oh, if we answer that, we will move forward. So yes, if I answer the question, what is the Wi-Fi password? First of all, what house are we talking about? Did we get any further on what we're trying to do over here?
I'm talking about the school Wi-Fi password.
So if what we're trying to do is, as we take a look at this, where's my annotating? Okay. You guys are all seeing the need to know board, right?
Yes.
Are you guys all seeing what I'm typing, the questions and everything?
Yes, ma'am.
I'm not seeing my annotating here.
What does that mean?
Okay. All right, so as we take a look at this, if we know we have 4 weeks to build a model, calculate an electrical bill, and draw electrical plans, which of these questions, if answered now, are going to move us forward?
How much
So,
energy needed?
how much energy is needed? What does that depend on, though?
How much energy is being used?
How many
much I need
appliances?
today is going to be different than what I need tomorrow. So that's a fluid question. That's something that I can't answer. I can say how much energy might be needed if I run these appliances.
And how many outlets they use.
Okay, the outlets might be important. Now, the other side is maybe asking too specific of questions. How many rooms? So if we say there's 8 rooms, okay, that gets us going forward.
Is that
Why
8
are we doing this?
bedrooms?
Because you're here to learn, right? But some questions like these, of course, okay, distractions, right? So maybe we don't need these questions that are in here, and we can take those out. So maybe a little bit of a distraction. But what appliances are needed? That might be relevant to what do we need in the home. But a good question might be, if I need to draw electrical plans, a very broad question might be, what? Instead of what is the IP address, maybe I should ask, how do I draw electrical plans?
Ma'am, computers generate those now.
Sometimes. If I have to build a house and wire it, build a working, I should say. So in 4 weeks, you must build a working model of a house. A general question might be, how do I wire a house? Right? I like, as far as, do we have a budget for the electrical bill? They want a low bill. How low? 0. That's how much I want to pay for my electricity, right? So as low as possible is going to be what my budget desires be. However, this is what you call with your standard of living, I guess you could say. For me personally, I love my hot water for the hot showers, because that is my one thing I would be happy to spend money on the hot water. However, we don't keep our house very cold in the summertime or very hot in the wintertime, because I don't want to spend a lot just on the heat. I'll just put on a sweatshirt or wear shorts, right? So for me, when it comes to paying the electrical bill, it's about what brings you comfort. And then you don't want to be living in such a discomfort that you're miserable, right? So how much am I going to be needing? So I like that. What do I have in my budget for the electrical bill? Because it meets what do we need to do. So the major questions, how do I wire a house, right? How do I draw electrical plans? And to summarize the other one, if we were to summarize, if I need an electrical bill, what is our budget? How much energy is needed? Right? How do I estimate the total electrical bill? Putting those together, we might want to ask in general, how do I calculate
Ma'am,
electrical bill?
if we're electrical engineers, shouldn't we already know how to do that?
You should, yeah. Do
Ma'am, I
you?
already put how do you estimate an electrical bill?
Okay, how do I estimate? That's a good one. I like that.
No, I already said that.
Down.
Oh,
Sorry.
okay. I missed that. So Ben, you asked a good question.
Yeah.
Okay. So all these other ones are good questions, and they might be what's on your mind, but part of the game of being successful and what you're trying to do is to clear your mind of all these distractions, of all these other things, and focus on what you need to get done. What is the task at hand, and what am I going to have to do to move forward? So we're doing all this online stuff. So obviously, how can we find out this information? We can definitely do what, Drew? What?
Google.
Okay, we can Google,
Yeah.
right? What else can we do? Ben, what do you think?
Phone a friend.
Phone a friend. All right.
Bing.
Bing?
Bing.
That's
Duck,
like
duck,
Google, right?
go.
Yeah, duck, duck, go.
All right, you
Duck,
guys are
duck,
thinking
go.
online now. We can definitely, attend class.
Good one.
Definitely. All right. So we are going to, I do have some scenarios. You can certainly ask me. Be happy to help you. I definitely want to help you try to figure all this out. What is,
Go to the library.
all right. They're all closed, unfortunately. Okay. So we want to move forward. My question to you guys is, what do you know about electricity?
I know my dad works for Dominion.
And does he? Cool. So maybe we can ask CJ's dad.
Probably.
Right? All right. Anybody else? Matthew, you have anything of how we're going to figure this all out? Is he still with us?
Watch a Khan Academy video.
We could watch a Khan Academy. You guys use a lot of Khan Academy, which is great. They're very good.
I actually don't.
I've never used Khan Academy in my life.
Okay, I am going to save this sheet. I'm going to stop our share for now. Come back together here. All right, let's move forward. How are we going to do this? So I'm not kidding you. I want you to build me a little model of a home. What do you know about electrical circuits? And how do they connect together? And what makes them work? All right, so we're going to do some online kind of lab things. And like I said, it's one of my favorite subjects to do. Unfortunately, we're not in the classroom to do it, but I definitely want you to get a taste of this. So as you move forward and you're making some career decisions, you can decide, that was pretty interesting. So when it comes to electricity, where does it all begin? What do we need to make electrical circuits?
A nuclear power plant.
Okay, it may not have to be nuclear, but we need a
Power source.
power source. We need something, right? So we need a power source. And what does that do? All right, what else do we need? Virginia Power's there, but it can sit there all you want. I'm going to need to.
Then you need cables to run the power to your house.
I'm going to need cables. I'm going to need wires, right? I'm going to need a connection. Now, we are living in a very wireless world, which is a whole nother type of electrical side. But we're going to take a look at, okay, I need wires. And then what else do I need?
You need to know if it's above or in ground.
Okay, we can put the wires above or in ground, but I can bring it to my house, but I need,
Power.
well, the power, so I need a light,
Lights.
right? We need lights. We need appliances that are going to use that electricity. So those are the three things, really, all that you need in a circuit. The power source, the wires that conduct it there, and the object that's going to use it. The question is, how do they connect together? How do I put all those things together to make that light come on? How does the electricity come from South Anna Power Plant, which is very, very far away? And no, when I flip my switch, I get that light on like that. There's really no time delay at all, right? So how does that all come together? All right.
Circuits.
In circuits. Okay, my question to you is, have you ever studied any circuits at all? Brendan, on a scale of 1 to 5, how much do you know about electricity?
1.
1. I should say 0 to 5. Is it a 0? Brendan?
That is a 1.
A 1. Drew, how much you know about electricity?
So yeah, probably a 1.
A 1. Matthew?
0 and 5.
1.
1. Jack? 0. Ben?
1.
1. Frankie? 1. CJ? 1. Brock? 1. Good, because guess what? You guys have a lot to learn. There we go. And that's why you're all here. So I'm glad none of you are 5, because you're going to learn a lot. All right, so let's begin with, how do I put all these things together? All right, if we were in the classroom right now, I would be giving you all a light bulb. and ask you to make sure you turn it on. That's the most common thing we put our electrical in, is lights. What you're going to find out, though, it's the cheapest thing. So we go around and we say, oh, shut off the lights to save electricity, but they cost hardly nothing to make. They cost a lot to buy. When I go buy light bulbs, I'm always like, man, those are expensive. But the actual use of the electricity to make the light work really hardly costs anything. So other things that you use to heat up your house, whether it's hot water, your stoves, your heating, that's where you put a lot of money into. Anything that's going to heat up costs a lot of money. All right, so paper and pencil, here's your first lesson. How do I make a light bulb come on? So I grabbed here Christmas lights, all right? And this is what you guys are going to use. So your homework tonight is to gather what kind of supplies you might have in your house. So with permission, do not take the lights if your parents do not allow you to, all right? So Christmas lights, we can cut apart. So you need to ask, because they will not be used again. You're going to cut them up. All right, so find out from your mom and dad, whoever does all the decorating, to pull out an old set of Christmas lights. They can be white or color. Preference is as old as you can get them, because they are not the LED lights. So most recent lights are all LEDs. They just will require a different amount of voltage. So here's a light, right? We said everything started through the power source. So the next thing I want you to try to find in your house, 9-volt batteries will give you the best. However, you can use any kind of battery. So if you have a AAA, AA, C, D battery, you can pull them out of something. So
Could I use a
yourself
car
some
battery?
batteries. What's that?
Could I use a car battery?
It's a little too much. It'll blow these lights. But you can, if you have one. We just need to hook up your lights differently. All right? So car battery, your lights, this. When you get your Christmas lights, what you will find is when you cut them up, all right? So if I take these lights, what you're gonna do is we're gonna cut them, all right? So you guys are telling me, and I don't wanna give you a lot of paperwork to do, so we're gonna have some fun. We're gonna wire some things together in class, all right? But you're all gonna need to supply your things, and if you don't have them, we'll just draw it out on paper. But I think you'll enjoy this. So when you take Christmas lights apart, all right, what you will find is I have a lot of extra wire there. So when you're taking these apart, you don't want to cut this wire. This is going to serve as wire that we can use then later. So Christmas lights are pretty cheap now. I know I have a ton of them. So hopefully, and if you don't have these supplies, I will put some things together in a bag, and you can go up to Benedictine and pick something up if needed. The preference would be that you're not traveling, that you can go up in your attic or wherever you store all your stuff and get yourself some Christmas lights. Don't take them apart yet. You can if you want, but as you take these apart, okay, so they're together. So what I'm gonna do is I need to take my scissors and I'm gonna cut them right in the middle of the next light, okay? You really don't need too many depending on what you decide you're gonna design. So that's what we're gonna use, and the question is, how is that light connected? And what's going on inside that light. So at the beginning of the year, I showed you a video, I don't know if you remember, about failing, the secret to success. And it was the Honda engine. And in that video, they ended it with the light bulbs. Anybody remember how many times it took Edison to design the light bulb? 10,000 times. He got it right, 10,001 times. So the question is, was all those other things failures? No, right? They led him to the success. So why did it take so much to design a light bulb? For us, it seems so simple because it, easily, I can connect to it. So if I connect it to my 9-volt battery across here, right, comes on. There you go. Why does that work? So simple, right? Now, so if you don't have the 9-volt, and again, it's not meant for anybody to go out and go shopping because you're all staying at home. Find this just within your house, Christmas lights, a light bulb, and some kind of box. So shoe box is perfect. And you might want multiple boxes, one to keep all your stuff in and one to build in. So your box is going to be your room that we're going to be using, okay? So in the meantime, I want to teach you a little bit about electricity. Why do I need a battery? What exactly is the battery doing? And what are the wires doing? And what's going on in the light bulb? All right, so I'm going to equate it to something that you guys are probably all very familiar with, which is turning on water in your house. So I always say with electricity, I know even for myself, when I first started studying it, my biggest struggle is I can't really see what's going on. I can turn this on and I see the light, right? The light comes on nice and bright. However, I can't really see what's happening inside here. So a mechanical system, it's easy to see when a screw comes off or something breaks. Oh, that's what I need to fix. When it comes with electricity, people think it's really, really difficult for two reasons. I can't see what's happening in there and where the break is, and it can hurt you. It actually can be very dangerous. So a 9-volt battery is not going to do anything. Car battery might shock you, but it's not going to kill you. But the wiring in our house can be very, very dangerous if you go to wire. So that's why it comes across as being difficult. People are afraid of it, and you really can't see it. It's abstract. So for those 2 reasons, but I will tell you, it is so simple. Electricity is so simple. All right, so you ready for our first notes on how we're going to wire things? And then your homework tonight is to find the supplies that you're going to need. All right, so let's begin with this. We're going to equate our electrical circuit with a water circuit. All right, so over here I'm going to say water circuit, electrical circuit. All right, so these are the 2 things you want to write down. So you will be graded at the end. At the end of 4 weeks, you're going to show me a room of a light that you can turn on with a switch and other appliances that might be in there. So pay attention, because this is, I'm not kidding. You are building me a model for this house. All right, so let's go back here. I'm going to switch and let's see. There we go. Okay. What's that doing? That's not what we want. Okay. Sorry, I'm trying to get my screen. There we go. Okay, so our water circuit. Now, first of all, I'm going to write some terms over here on the right. So if you want to write these things down, let's see if we go like that, so you can all see that. Okay, so a circuit is simply a pathway. So when we talk about a water circuit, it's a pathway for water. An electrical circuit is a pathway for electricity. So in your house, how do we get water in your house? Some of you might have a well, right? So you might have a well, and the reason, nice rainy day like today, all that rain is going where, Matthew? Coming from the sky, and where does it go? Matthew, I think you're muted. Where does the rain go?
In the well.
In the well. It goes down and down and down and down as low as possible, right? So here's all of our water, way down low. How do I get it to my house? What am I going to need?
A pump.
A pump, right? So I'm going to just symbolize it like this. What we need in here is a pump. And the purpose of the pump is to take the water from where it wants to be, which is the lowest part in the ground. All this water is going to flow and flow and flow until it gets to the lowest point. That's where it likes to be. We need a pump to put it where we want it to be. So a pump raises the water from ground level. Right? So it's going to raise the water from ground level. In our electrical circuit, what do we use? A battery. So you have your positive and your negative end. All right? So I'm actually going to draw it like this. I'm going to put our negative on this side. All right? So what's our battery going to do? The purpose of the battery raises the electrons to a higher potential. Okay. Over here, we didn't study energy, but I'm sure you did in the past. This is at the lowest gravitational potential energy. What the pump is going to do is raise it to have a higher potential energy. The same thing over here, we call that electrical potential. The battery is going to lift the electrical potential of the electrons. So you may or may not know that a battery literally has two parts to it. We have the positive side, usually that's our red, and it contains a lot of positive ions. And then we have the negative side. They are totally insulated from one another. So as we learned when we went to Jefferson Laboratory, these want to be together. Our natural state is that everything is neutral, so that all those positives and negatives mix together to make things neutral. Just like the natural state of water is to be as low as possible, the natural state of our charges is to be mixed and to be neutral. So what a battery does is it separates them and puts them where they don't want to be. Separated, positives and negatives. So now if they are separated, they're going to want to flow to get back together. If I have the water where it doesn't want to be, it's going to want to flow to get back to where it wants to be. So getting back to our water circuit, right? Brock, easy question. Our water's in the ground. What am I going to need to make sure that that water gets to my house when I pump it out of the ground and it doesn't just go all over the ground?
Like a pipe.
Very good, a pipe. We're going to need a pipe. So in the pump, right, what we're going to need as we pump that water out, we're going to take a pipe and we're going to lead that pipe over to where we want it to go, right? So that that water doesn't just go anywhere. So pipes direct the water to where you want it. Right? In our electrical circuit, CJ, what are we going to use to get these electrons where we want them?
A wire.
A wire. Right? So we're going to use a wire. It's going to lead those there. Now I'm not going to use my house. I'm going to use the old school water wheel because it gives a better visual of what's going to happen when I take this water and I release it. So we discovered that this water, when released, is going to naturally fall down. As it falls down, I'm going from a high energy level to a lower energy level. So I want to be able to take that energy that the water's carrying and turn it into something else that I want to use. So we discovered the water wheel, the old time mills, and they took buckets of water and they connected them to, right, a basket of sort, right? And then they're going to collect all this water on a wheel like this. So when the water hits it, this water falls down. And what does the wheel do, CJ? The water hits this wheel, it's going to
Spin.
spin. So now I get rotational motion out of water simply falling back to the ground. I had to raise the water up. Now we were smart and built these up on mountains where the water's running down through the creek because it's naturally going to go towards the ocean. So if I can put something in there as the water wants to fall, I get a different type of energy out of it. And in this case, rotational energy. So what we want to say here is as the water falls, energy turns into rotational energy. Right? So I put something in there to catch the energy. And then if it is a circuit, I want to catch all that water and then send it back into my well, right? So then I can reuse it. That would be a complete circuit. So you guys have a visual of that. In my electrical circuit, I'm going to stick something in there. So when these electrons fall to where they want to be, which is next to the protons, I get something else out of it. And what I'm going to put in there is a light bulb. The key on the light bulb is, how do I get that light? It's going to fall through the filament, and it actually comes back out of the bottom of the light bulb. And the difficult part of the white light bulb was keeping it so that this filament stayed separated. So when the light comes in, or the electricity comes in, as it falls down, fall to a lower energy state, you get light. Okay? So you're literally making these electrons fall down. Except in electricity, falling could be either direction. It can be up, actually. I can make things work up. All right, so I am about out of time, or I am out of time. So that gives your basic scenario of what we need in our circuit. We need a power source. So your homework tonight, everybody find a power source. If you're getting this kind of a battery, a 9-volt, one of them is enough. If you have these batteries, get a couple of them, and we're gonna have to combine them together to increase their voltage. I'm gonna talk about that. Find yourself an old set of Christmas lights and get permission. I don't want any emails from parents saying that you cut up Christmas lights and they're devastated. Make sure they're nothing that they can't do without, and that they remember next year when they go to set up and decorate that they don't have those Christmas lights, all right? So find yourself Christmas lights, and find yourself some kind of box. I don't care what kind of box. So it can be a packaging box. It can be a paper box, okay? A shoe box works best. So what you're basically going to do is this box is going to turn into a room that you are going to wire and put lights all through it and decorate. All right? Make sense? All right, so tomorrow, to get credit on your homework, you're going to show me a box that has stuff in it that you found, and you're ready to go. All right?
How many lights?
What's that?
How many lights is it gonna take?
Well, that's up to you. So what we'll have to decide next is who wants what room. So the other side of your homework is I want you to think of what room in your house you all want. So we need a bathroom, we need a kitchen, we're gonna need a living room, bedrooms, right? So I want you to pay attention in your house, the wiring, and you're gonna mimic that room that is in your house. The kitchen is by far the most difficult. It has the most stuff in it. Extra credit for whoever wants to tackle the kitchen.
So if you just do a bathroom, then it's only like 3 or like.
Well, that might be your bathroom, but we'll have specifications from this family of what they want in their bathroom. So most bathrooms, you have kind of a chandelier above a mirror, and then you might have a single light that's within the room itself, or the lights above the mirror are the only ones. But that's what I want you to start paying attention to. What does the wiring look like in your own house? And if it was your dream house, that's the reason you have a custom-built house, is you put things in it that you want specifically. What would you put in your dream house? Would you want more lights, more switches, more outlets? I always say I want one switch to turn on all the outlets that are below the windows in my house, so I can turn on my Christmas lights all at once. I do know some people that have that. One switch to turn on specific outlets in the house, so whatever's plugged in there gets turned on at the same time. That's pretty cool. Anyway, so think about those kinds of things, what things you might want in your house, okay? I hope you guys have fun. This is not meant to cause stress, but rather that you learn something very practical, because I hope your goal is to own a house someday. And I know myself, we've even cut holes in our ceilings. I put in our lights. I changed our lights out. It's really simple to do. Something now, if it's more, detailed, you want to hire somebody, but changing out lights and putting in new fixtures and stuff is not a difficult thing in your house. So hopefully that's something you all get to do someday. All right. So I'll see you Wednesday. Hope you have a great day. Any particular questions? Everybody good on what you're finding for me?
See you, Coach.
All right. Go invade your attic. See those Christmas lights. All right. Have a great day.